So what I'm going to do is try to draw the marginal cost curve here and average cost curve. Okay. The marginal cost curve is the slope of this line, correct? So the slope of this variable cost curve, it decreases first. Decrease first. After the inflection point, it's going to increase. Okay, increase. So the cost curve is here. This is the inflection point. So it's something like this. Okay. Now look at in that graph, we never had that. This is the marginal cost curve. Okay, we never have this declining portion of the marginal cost curve. Because what? Because that technology is concave everywhere, correct? So, but here, this function, we have some convex portion here before the inflection point. So you have a declining portion of the marginal cost curve. Okay. Average cost, okay? Average cost is, for a particular point on the variable cost curve, it's a slope of the line connecting that particular point with the origin. Okay? Look at as I move along this cost curve, this slope is declining, right? Average cost first declines. Okay, but it declines. There's a point here. You cannot decline further. That's the lowest average cost point. Then beyond that point, your average cost is going to increase. Okay? So it's here. Average cost. Wait a minute, am I right? Sorry. This is wrong. And there's another property of this point. This is a point where marginal cost is equal to average cost. The slope of the variable cost curve is equal to the slope of the line connecting this point and origin. Okay? So it's this. That's my marginal cost, average cost. Okay? So in the textbook, we don't have this portion. The marginal cost is always increasing. Average cost decline first and then increase. Okay? Because usually we assume the production function is concave. Okay, this is pretty interesting here because we have something very similar in the in the production function analysis. We also have 3 stages here. I'm going to call this stage 1. And this is stage 2. Probably up to this point. Stage 2. Okay? Make sure the average cost cannot increase beyond that. It will increase. But your y cannot go beyond that. It's going to increase this way. Gets very high if you continue to increase your input use. Average cost. But there's no stage 3 because y cannot go beyond that point, right? In this variable cost. Recall what we did in the production function analysis. This is the inflection point, and this is where your elasticity is equal to 1. We have something look like this. marginal productivity, average product. Marginal productivity becomes 0 when I reach the maximum y. Okay, becomes 0. And this is stage 1. Correct? Where marginal productivity is higher than average product. So elasticity is greater than 1. Okay, let me write this. Elasticity is equal to marginal product divided by average product. That's y. That's greater than 1 in stage 1. Okay. This is stage 2. It's less than 1. Stage 1. Stage 2 is between 0 and 1. Stage 3 is less than 0. Okay, that's stage 3. Again, this marginal cost curve has to do with the marginal productivity curve. Okay, it's kind of the inverse of this if you look at here. Okay. And average product has to do with average cost. There's a one-to-one correspondence between the cost function and production function and the associated functions. Okay. Are you guys following me on this? It's pretty clear, right? So the key point here is, okay, we've been seeing the cost function, marginal cost function, average cost function. I think I want to emphasize here is these functions are determined by the production function, by your technology. If you use a better technology, your cost will be lower. That's simple. Okay. I guess next thing we're going to do is to define this so-called flexibility of variable cost. This is a kind of a flexibility is another way to say elasticity. Okay, so that by definition, it's defined as the infinitesimal percentage change in variable cost. Okay, when I change my output by an infinitesimal percentage. Okay. So here's the marginal change in variable cost as a percentage in terms of the variable cost in response to a percentage change in the y. So along that expansion path, basically, if you increase your output level by a small percentage, how much your minimum cost will increase as a percentage. Again, any elasticity can be defined as the ratio of the marginal function to the average function. Okay, so here we got marginal cost divided by average variable cost. Okay, look at here. That's the ratio of marginal cost to average cost. At each point, it's pretty easy to look at here. Okay? In stage 1, marginal cost is lower than average cost. Correct? I'm going to write stage 1 here. This epsilon variable cost. The variable cost flexibility is a number greater than 1. Correct? Marginal cost is lower than average cost. Okay? Well, that in English that means. Am I right? No. It's a number between 0 and 1. What does that mean? That means if I increase y, my output target, okay, my variable cost is gonna increase less than proportionally if I increase y. Or okay, if I increase my output level by 10%.